due diligence on the possibility of endangered species. These tend to be going in very high leveraging, and this leveraging, of course, can increase your ROE. Debt always seems to be cheaper, or it is cheaper than equity, and this emphasizes the need to be accurate on the risk. So this just, again, is a small example. You probably know from real estate that the more you borrow, the better your return looks. However, you better also look at a risk-adjusted rate, because it's the rule of thumb: the higher the risk, the higher the return. So basically, I've summarized the characteristics of project finance. So it's ring-fenced. Bankruptcy is remote. It may have some negative covenants on it in terms of what happens if it doesn't reach certain levels of performance. Typically, they're greenfield projects. And what I mean by that, they're new projects. They're usually single asset, and that's because the concession agreement is based on a piece of land. Going back to my first slide, how do you deal with it when it's tied into a piece of real estate, like a transportation terminal where the train goes through? Then you may have to think of strata title and so forth. We do brownfield now, where in fact it's the complexity is a lot greater. It's non-recourse. There's no guarantees from the equity sponsors. High leverage and reliance on forecasted cash flows and contracts. So you've got no history. Absolutely no history. Little reliance on physical asset. Lenders may give you some value, but usually not. And the revenue is provided through off-takes agreement. That means your agreements that in the future. It has to have a finite life, and also in some cases it would depend on the life of the oil and the gas. So if you were doing a refinery, you would have to know what's the life of the reserve. So some projects, or if you're doing a mine, you would have you don't say it's 30 years. You would have to then look at the length of time it would take to extract that mineral or that oil or that gas. So if you look at the requirements, it has to be a technically feasible solution. So if you're building a refinery or a wind farm or a solar farm, it has to be something that actually can be proven to work. In other words, it has to be capable of the output that the design is anticipating. And it's a big issue with wind farms. What happens when the wind doesn't blow? Wind farms are rather interesting. Economic viability. Yeah, one of the issues we're having with wind farms is that people are complaining that there's a noise that keeps them awake at night. They can't, I don't know if you have the same problem, they can't find the noise, but the politicians are using it to stop wind farms, or like off Cape Cod, where they don't want to see the wind farms in their view of much opinion. It has to be economically viable, having no track record of this in the past. It must be sufficiently robust in the face of adversity, and availability of raw material and capable management. One of the issues in India is that people like GMR and others have built all these energy plants, all dependent on coal. The only coal supplier in India is the government. And the government hasn't been supplying the coal because they've run into problems with communities and extracting the coal. So now these power plants have no energy coming in. And You're also going to look at, you can imagine how important capable management